Okay, so in this video we're going to have a look at the product rule. So again, it's in our log tables, we don't need to memorize it, but the more times you use it, the more familiar with it you'll get. So when we're dealing with product rule, we have a function where it's clear that there's two different parts being multiplied together. So if we look at part 1 here, I have two different brackets, so there's my u part and my v part. So I'm going to differentiate. Du dx will be 3 and dv dx will be 5. And now all I'm going to do is sub into my formula. So f dash of x is equal to u times, so that's 3x plus 1 by dv dx, which is 5 plus v times, so that's 5x plus 2 by du dx, which is 3. Brackets being multiplied, so I'll tidy up. 3 5s are 15x plus 5 plus 5 3s are 15x plus 6. And again, just like with like 15 and 15 will give me 30x plus 11. I've gone as far as I can, can't simplify anymore, so that's part 1 answered. Part 2 now, we see we have two functions here. Our differentiating for this will be a little bit more awkward. So for du dx, I have root x, which I need to rewrite as x to the power of a half, and now I can go and differentiate. So bring down your power, so a half, x stays where it is, and it'll be a half minus 1. So safest is to put that into your calculator. So you'll get a half x to the power of minus a half. And then for v, a bit more straightforward, dv dx is equal to 2. So I'll sub into my formula. F dash of x is going to equal u times, so that's root x dv dx, which is 2 plus v times du dx, which we know is a half x to the power of minus a half. So a bit of tidying up here to do. So we get 2 root x plus 2x plus 4 stays as is for now. A bit of tidying up. So I have a half x to the power of minus a half. I'll keep my half where it is for now. X to the power of minus a half will become 1 over x to the power of a half. So we have 2 root x plus 2x plus 4 multiplied by 1 over 2 times x to the power of a half is root x. So we're still tidying up the same section. So we get 2x plus 4 over 2 root x. So I see for my fraction there, I have 2 in common. So I'm going to factorize out on top. So we get 2 root x plus 2 bracket x plus 2 all over 2 root x. So my 2 and my 2 will cancel. So then I'm left with x plus 2 over root x. Tidy up again. So we get x over root x plus 2 over root x. And then your calculator, if you check any number over the root of itself, it'll just give you back the root of that number. So we'll get 2 root x plus 2 over root x. So for like with like, we have 2 root x plus 1 root x. So my answer at the end is going to be 3 root x plus 2 over root x. And that's part 2 answered. And now we come and have a look at part 3. So part 3 is kind of a little bit tricky. Initially we look at it and I see here I have one function and another function. But then within my second function here, I'm dealing with the composite. So it's going to be a combination of product rule and composite. Product rule and chain rule for a composite function. So I've isolated my u. So du dx is equal to 2. That's fine. And my v is equal to 2x plus 5. So I'm going to do a little bit of work here to the side to figure out dv dx. So my outside function is 2x plus 5 to the power of 3. My inside function is 2x plus 5. Differentiate our outside function, du dv, and I'll get 3 bracket 2x plus 5 to the power of 2, and dv dx is equal to 2. And then going back to chain rule, we're going to multiply them by each other. So f dash of x will be equal to 3 bracket 2x plus 5 to the power of 2 multiplied by 2. Constant here, so I can multiply in. So I'll get 6 bracket 2x plus 5 to the power of 2. So there's my answer for dv dx. Now I'm good to go. So here was my chain rule. So it's possible to have multiple rules within the one question. So back to our product rule, which was f of x is equal to u times dv dx. That's a v plus v times du dx. So my u is 2x, dv dx is 6 bracket 2x plus 5 squared, plus my v is 2x plus 5, and du dx then just gives me back 2. So now I have a couple of brackets. I'm just going to multiply it and then tidy up. So here I have 2x and I have 6. I can multiply them. So we get 12x bracket 2x plus 5 squared plus, and this second bracket I can leave as b. Sorry, for v here it should be 2x plus 5 cubed. So at the end we'll just have 2 bracket 2x plus 5 cubed. And that's us done for part 3. So it's a little bit more of an awkward question in the sense that it was a combination of rules, and you needed to recognize initially that you had product rule, and then within the product rule you needed to deploy chain rule. But once you recognized that, it was just a case of following the process. So always for these questions, start off following product rule, and then once you reach your composite function, you'll take a side step. So like our workings in green here, you'll take a side step, and essentially it's kind of rough work to go and figure it out. And then just sub back into your original formula, which for us here was product rule. And then after that you're just tidying up, multiplying out if need be, like what like. Just depends on the question layout. So that's us done for those 3 examples on product rule.